Yes, hello, is this audible? Madiha?
Yes.
Alright. So, Madiha, we had started with the unit electrostatic unit, and in this you have two chapters, electric charges and field, and the other one is electric potential and capacitance. So, we had started with this first chapter, electric charges and field, which is the first chapter of your class 12 NCRT part 1. Now, in this, we had started with electric charge first. So, electric charge is basically the intrinsic property of matter that gives rise to different phenomena. Now, these phenomena can be electric forces, these phenomena can be electric field. So, electric field we are currently doing. Electric force, you have a separate law for it. Madhya, what is currently, which chapter is currently going in your school in physics?
We just completed current electricity, the third chapter.
Okay. All right. So see, since this is your new batch, so we have to go through electrostatics only. But if you have your unit test or if you have your exam, then you just tell me. We'll be able to cover it. All right.
Yeah, I have my exam starting from 19th of June.
19th of June. And what is the syllabus?
It's the first two chapters only, this one and the electric potential and the capacitor.
This one, first two chapters, no?
Yes.
Okay. And it is on 19th June. Fine. So till that time, first chapter will be done. And if required, you can join the other batches for the completion of the second chapter. Fine.
Okay.
So see, electric charge is the basic property of matter and the SI unit is coulomb. CGS unit is electrostatic coulomb. So you have to remember the SI unit of electric charge and CGS unit. Now, charges are of two types, which you are already aware of, positive charges and negative charges. This was given by Franklin, positive and negative charges. Now, the charge that a single electron contains, this value you have to remember, which is 1.6 into 10 to the power minus 19 coulomb. This value you have to remember. So if it's electron, you can write it as minus 1.6 into 10 to the power minus 19. If it's a proton, you can write it as plus 1.6 into 10 to the power minus 19 coulomb. This is the electronic charge. You call it as the electronic charge. This is the minimum value that can exist in nature in free form, 1.6 into 10 to the power minus 19 coulomb. So for all the negative charges, just add a negative sign. All the positive charges add a positive sign. Now, to understand what is meant by charging and redistribution of electrons, first understand what the structure of an atom. So this you have already studied in detail in your class 11th in chemistry, structure of atom. Now see, the nucleus holds the proton with the help of nuclear forces, and the second force that are getting generated, these are the electric forces. Electrons revolve around these nucleus with the help of electric forces only. But there's a relationship between the nuclear forces and the electric forces. This is the relation. That nuclear forces are stronger than electric forces. It means the nuclear forces are approximately 100 times stronger than electric forces. So what happens? Nuclear forces are so strong that they do not allow the proton to move out. But electric forces, which are comparatively weak, they can allow the electrons to escape because the bond is weak, so bond will be broken easily. So since nuclear forces are very strong, they do not allow the protons to move out, while the electric forces are comparatively weak, they allow the electrons to escape or move out. Now, this shows that only the transfer of electrons occur. It is not the transfer of protons that occurs that makes a body as positively charged. From the body that loses electron, that body becomes positively charged, means the deficiency or vacancy of electrons creates positive charges. And the gaining of charges, like gaining of electrons, that results into negatively charged body. This is the basic mechanism of transfer of electron. Now, in this, you have to remember, if electrons are not massless entities, electrons do have mass in them, the way electrons have charge in them, 1.6 into 10 to the power minus 19 coulomb. Similarly, electrons have mass also in them, 9.31 into 10 to the power minus 31 kgs. So if a body is having equal number of electrons and equal number of protons, then you call that body as a neutral body. Means neither positively charged nor negatively charged. But if the body somehow gains electrons in this manner, then see, the associated mass of the electron will also come. This electrons number in this electrons number has increased. So masses of electron will also get increased. If masses of electrons get increased, then mass of the whole body will get increased. So for the body that gains electrons, it becomes what kind of charge? It becomes negatively charged and it has gained mass, means mass increases. Just opposite case is the case of when the electrons get moved up. If electrons are getting removed from the body, if electrons are somehow getting removed from the body, no, then see the mass will also be decreased because this mass has been cancelled now. Initially there were masses of 4 electrons. Now one electron has been removed. So now the masses of electrons are getting removed. If masses of electrons get removed, then the whole mass of the system decreases. So for positively charged body, electrons are lost and body's mass decreases. For negatively charged body, charge gains electrons and the mass increases. Is this clear till here, Madiha?
Yes, ma'am, it is clear.
Now see, there are various methods of charging this. This transfer of electron from a body, from a positively charged body to a negatively charged body. This is known as charging also. You call this transfer of electrons as charging. So there are 3 major methods to perform this process of charging. One is charging by induction, other one is charging by conduction, and the third one is charging by friction. So first one is very easy, charging by friction. This is very easy because you have already studied frictional force in your class 11. So charging by friction is comparatively easy. In case of charging by conduction and charging by induction, these are new topics. Now in charging by friction, what happens? Frictional force is what? This is the force that comes into action whenever a body is in motion. So frictional force goes into the opposite direction to oppose the motion. So when two bodies are rubbed together, if two bodies are physically rubbed together past each other, then electrons do get transferred by the heat that is generated. That is charging by friction. Now, if I do not rub the bodies, if I just place the two bodies in contact and the charges are getting transferred, then you call it as charging by conduction. In case of charging by induction, that I'll show you. But in case of charging by conduction, remember one thing. If your bodies are identical what? If you have two spheres and the radii of both the spheres are equal, then you can directly say both of the bodies are identical. Or if you have two cubes with you, the side of the cube is A. Let's say the side of the cube is A. So both of the cubes are having the same side. It means both the cubes are identical. So if you have identical bodies, then the charge gets divided equally. Whatever charge distribution occurs, whatever transfer of electron occurs, this occurs equally. Means if there are 4 electrons, then each of the body will receive 2 electrons. This is charging by conduction and that was charging by friction. Difference lies in frictional force. Both the bodies are moved, means motion occurs. In case of charging by friction, you don't rub the bodies. You don't rub the bodies, you just place them in contact with each other. Now, charging by induction. With the help of this figure, you will be able to understand. See, in case of charging by induction, what happens? You have a neutral body, supposedly. Neutral body means what? Number of positive charges are equal to the number of negative charges. So, if I somehow bring a glass rod, which is having positive charge in this manner, this glass rod, it is having positive charges here in this manner. Now, positive charges will attract what kind of charges, Madhiya?
Negative.
Negative charges, definitely. So what happens? All the negative charges that are residing in this neutral conductor, they will get accumulated after a certain period of time because of the attraction of the positive charges. And over time, what will happen? Since all the negative charges are coming at one end, the other end will develop positive charge, because the other end is what? Left with positive charges. So you have easily separated positive and negative charges. Now, till the time you are holding the glass rod, this is having the negative and positive charge. So that's why we call it temporary electrification, because as soon as you remove the glass rod, both of the negative and positive charges will recombine with each other and result in the formation of neutral body back. So this process, when a charged body is placed a neutral conductor, it induces charges due to redistribution of electrons. This is known as charging by induction. So these are the three methods of charging. Any doubts till now?
No, ma'am.
All right. Now, next, what we had already covered is Coulomb's law. So I'll be briefing you with Coulomb's law. So you will be able to cope up with electric field today. We are currently doing electric field. Now see, in Coulomb's law, what happens? You have two charges kept together. Q1 is one charge, Q2 is another charge. So in Coulomb's law, if you have two charges kept together with a certain separation between them, so Coulomb's law says that whatever is the magnitude of both the charges, just multiply it, and electric force will be proportional to it. So electric force is proportional to the product of magnitude of both the charges. For example, this is an example that I was teaching. One charge is 2 coulomb, other charge is minus 3 coulomb. When you are considering the magnitude, you don't consider the sign as positive or negative. Let it be positive, let it be negative. You just have to consider the magnitude. So this is 2 coulomb, this is 3 coulomb. So 2 multiplied by 3 is equal to 6. This will be the 6 coulomb square. This will be your charges. So electric force will be directly proportional to this only, product of magnitude of charges. And it is inversely proportional to the separation between them, square of separation between them. These are the two statements of Coulomb's law. Electric force is first directly proportional to the product of magnitude of both the charges, and electric field is electric force is inversely proportional to square of difference separating the two charges. So this is how the proportionality will be looking like. Now, if I remove the proportionality sign by some means, let's say I've removed the proportionality sign, so I get a constant. So this forms your Coulomb's law formula. F is equal to K Q1 Q2 divided by R square. This is your Coulomb's law. Now, let us just elaborate on this constant that we are having. Always remember, whenever you are solving these formula of Coulomb's law, then put the value of the K constant as 9 into 10 to the power 9. How? See, K is actually 1 over 4 pi epsilon naught. Epsilon is what? This symbol, this E symbol, this is called as epsilon. This is a Greek symbol. This is known as epsilon. This means absolute permittivity. Absolute permittivity is what? It tells you the nature of force in different medium. You have different media with you, there will be different values of electric forces that you will be getting. For example, if I take the two charges and I put them in air, I'll be having certain force. If I put those two charges only in water, then the value of force gets changed. So this governance between the charge, between the force and the medium, this is governed by what? This is governed by absolute permittivity, whose symbol is epsilon. So this has different value for different media. For glass, you have a different value. For water, you have a different value. For alcohol, you have a different value. For air, you have this value, 8.85 into 10 to the power minus 12, which you have to remember because this is the standardized value. This has been done experimentally. It has been calculated 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. This value you have to remember. If medium gets changed, you are given a new value, then you will be getting it. You don't need to remember it. You just have to remember 8.85 into 10 to the power minus 12. Now, if I put all the formula for it, 1 over 4 pi epsilon naught, I know what is 4. I know the value of pi. Pi is always 3.14. And if I put the value of epsilon naught as 8.85 into 10 to the power minus 12, once you will solve this, no, you will see your answer is coming approximately 9 into 10 to the power 9. That's why whenever you are using Coulomb's law, you have the value of this charge, you have the value of this charge. If you know the separation between them, put the value of K as always 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is Coulomb's law. Clear? Coulomb's law?
Yes, ma'am.
So the current topic that we are doing, this is electric field. Now just understand electric field is what, and this is easy. This becomes easier for you to calculate. Basically, every charge has a certain space around itself. If you bring another charge in that space or region, you will be able to feel repulsion or attraction. For example, if I have this charge, capital Q with me, plus this is a positive charge. If I bring up a negative charge, will I be able to feel attraction if I bring up a negative charge to this positive charge? Yes or no?
Yes.
Yes. And if I bring up a positive charge, then I'll be able to feel the repulsion. But just tell me one thing, Madhya. Do I need to move both the charges and place them tightly in contact, or after a certain distance I'll be able to feel the repulsion or attraction?
You can feel after a certain distance.
At a certain distance, I'll be able to feel. The reason is what? Reason is this, that each charge generates its own electric field, where electrical phenomena, electrical properties can be experienced. Electrical properties means like forces of attraction, forces of repulsion. Even if I bring this charge near this charge, I'll be able to feel a positive repulsion because of both the charges being positive. So this space around the charge that generates this field, this space to help us in calculation or experiencing electrical properties or electrical phenomena. This is known as electric field. This is the meaning of electric. So we call usually this charge as source charge, which is the stationary charge. This is static, at rest. And we call this charge, this is the charge, moving charge, as the test charge. So this is what is meant by electric field. So electric field has a direct relationship between force. Electric field is actually force divided by charge. Now force is what? SI unit of force is what?
Newton.
Newton. And charge SI unit is?
Coulomb.
Coulomb. So SI unit of electric field becomes Newton per Coulomb, which is also called voltmeter. And how is it voltmeter? That we'll see in potential and capacitance. You have a relation between electric field and potential, there you will see. But right now, for the concern of this chapter, you have to understand the electric field is force divided by charge. Now, derivation of electric field for a point charge. See, if I put the value of force as K capital Q small q by R square. See, if you apply Coulomb's law in this case for source charge and test charge, you'll get the Coulomb's law in this manner. Now, if I put this force here, charge will cancel and I get electric field as KQ divided by R square. And K was what? K was 1 over 4 pi epsilon naught. If you put this, you will get it as Q divided by 4 pi epsilon naught R square. No need, you can always write K as 9 into 10 to the power 9. No need to write every time 4 pi epsilon naught. Now, see, electric field is equal to force divided by charge. If I put the electric field's value as plus 1 Coulomb, will it be electric field equal to electric force? Madhya?
Yes, it will.
Yes, it will be. So it means we can define electric field as electric field is actually the force that is experienced by what? A unit means one positive test charge. All the force that is experienced by a unit positive test charge, this is known as electric field. Now, this is the general formula of electric field, KQ by R square. If you have positive charge with you, then the direction of field is given by moving away from the charge. For example, I have taken this point. Let's say this is point E. This is my positive charge. If I move myself in this manner, I'll be going towards the charge. But for a positive charge, what did I tell you? You have to move away from the charge. So this will be the direction of electric field for this point. Similarly, if you have all the points and you have a positive charge, electric fields will be away from it. Opposite is the case of negative charge. You have to move towards the charge if you have a negative charge. For example, if I give you this point E, then electric field will be directed towards this. This will be the direction of electric field. That's how you calculate. And then we had seen few graphs. See, basics of graphs is what? If y is proportional to x, means if you get a linear equation, then you get a straight line graph, both are proportional to each other. If it is a quadratic equation, then you get parabolic graph, which is in this manner. And if you get inversely proportional relation between any property, then you get a hyperbola. These are the basics. So if you have force versus r square, F is equal to kq by r square, means force is inversely proportional to r square. So you get a hyperbola, the third case that we had seen. And similarly is the graph of electric field. Electric field versus r square will be what? Electric field is inversely proportional to square of r. So this shows that this is the relation between electric field and r. Clear, Madhya? Any doubts till now? Any topic that you have not understood?
No, ma'am. So basically, for electric field and force, the formula is kq by r square.
Kq by r square. If you see, it is F by Q. Now, since we know the formula of force, if you put it, you get kq by r square. This is the main formula for a point charge. Remember, it is for a point charge. We will be studying most probably in today's class only. If we are permitted with time, we'll see. For different charges are there, combinations of charges are there, you get it different. But if you have a point charge or if you have a sphere, for both of them, it will be kq divided by r square. So if both the charges are same, force becomes kq square by r square. If electric field is there, this is the electric field. All right, Madhya. So just let's take a break of 5 to 10 minutes till other students are joining. If you have any doubts, you can text me meanwhile. All right. So we'll just stay connected. Other students will join. After 5 to 10 minutes, they'll be joining. Yes, class. Is this audible to you all?
Yes, ma'am.
All right. So in the last class, we had covered till here the graphs of electric field and forces, how to see all the graphs and check for it. So any doubts till now, just ask me. Direction of electric fields we had seen, electric field for a point charge we have calculated. Now, what if different electric fields are given to you? If I say not a single charge is there, suppose I say that this is Q1, another charge is Q2, and let's say n number of charges are kept. Let's say plus Qn are kept. And at this single point, let's say this point is some T point, I want to find out the electric field. See, electric field will there be definitely because of this charge. Q1 will be having electric field at this point. Direction will be away. For a point charge, remember always, for a point, positive point charge, electric field is directed away from the charge. So electric field 1 will be this in this manner. Similarly, if we talk about the second charge, this charge, electric field will be directed away from it. Electric field will be directed away from it. So this will be the direction of E2. So in this manner, n number of charges are kept. So n number of charges will also be having the direction E, and this will be the direction. Just remember, at this point P we are calculating. Electric field is directed in this manner, away from all the charges, in this manner. These are all the charges that are kept together. Now, when we had single electric field, we knew how to solve it. But if you have so many number of charges that are interacting and you have to find out the net electric field, then understand net electric field, this is given by the sum of individual electric fields which are added vectorically. See, what did I say? This principle is known as superposition principle. Superposition principle. This is known as superposition principle. This means what? The net electric field in this region, whatever is the net electric field, this will be given by vector sum of all the electric fields. Even if there are n number of electric fields, the net electric field we will be given by vector sum. Remember, this is not the algebraic sum. The reason electric field is a vector quantity. It has magnitude as well as it has direction with it. So if it has direction, how can we neglect the direction? Vector quantities obey vector laws. So you have to add all the electric fields vectorically. So for a system having n number of interacting charges. N number means what? It can be 1, it can be 2, up till infinity, it can be any number. N is not specific, it can be any number. So if you have n number of interacting point charges with you, then net field at any point, this is vector sum. Always remember, it is vector sum. If you remember your parallelogram law, triangle law, all the vectors laws, that will be considered over here. So at any point is vector sum of field due to individual charges. If you have Q1 with you, Q2 with you, just keep on taking the direction, whatever directions are possible, and ultimately at the end you have to add them vectorically. This is what is meant by superposition principle. This is a very easy principle. All the vector laws that you have studied, all parallelogram law that you have studied, I'll repeat it once today. In today's class, I'll revise what are your parallelogram law for all those who are forgetting it. Otherwise, superposition principle is the simple statement only. Now, one more thing before I forget, just make a note point and add into your notes. Neutral point. because this will also be utilized a lot. See, neutral point is that point where net electric field is zero. All the individual electric field cancel each other. For example, E1 is there, E2 is there. If I say at this point, both the electric fields are canceling each other. So this becomes your neutral point. This is your neutral point. So no electric field line passes through. We have a separate topic, electric field line, that time we'll discuss. But right now, understand neutral point has what? No electric, net electric field is zero. So quickly copy superposition principle, then we'll do a numerical, which will include your concept of electric field for a point charge as well as your concept of neutral charge. All of you have written the theory part above it?
Yes, ma'am.
All right. Now let's discuss the question, how to deal with such kinds of questions. See, you can get these questions in case of Coulomb's law as well. Means right now you have to calculate what is the net electric field, where the net electric field is zero, that point you have to calculate. Similarly, it can be calculate at what point the two charges have their net force as zero. So concept will be the same. So you just understand it for electric field, even if you get it for your electric force. The concept will be the same. So it says what? There are 2 point charges. Let's take 2 point AB. So A is having plus E, B is having plus 4E. This is the case that we have. Both of these charges have a separation. This is A. Both of them are separated by this distance A. You have to understand, you have to take out a point where the net field is 0. Now see, since in this system we have no information, net field is 0. Right now I told you. Can anyone tell me which is this point called as? What is this point called as?
Neutral point.
Neutral point.
Yes, Stream and Samya. This is called as a neutral point. So even if the question asks you what is a neutral point in this, what to calculate the neutral point, then immediately understand your net electric field is 0. In this question, it is clearly mentioning you that electric field is 0. Even if it says neutral point, the concept will be the same. So now see, we don't know what is where the neutral point is located. So best way to solve it, take any point. Let's say I have taken this point as my neutral point. Never take it in the symmetry at the center unless and until you are aware of. When to take it at the center, that I'll tell you after this question. So I have taken a random point, neutral point. Let's say the separation between the neutral point and this A point, this is X. So can anyone tell me if this whole was A, this small part is X, what will be this? See, this whole separation is given A. This part, this is I have taken as X. What will be the other part left?
A minus X.
Yes, correct. It will be A minus X. Fahad, it will be A minus X, not X minus A. X is a smaller part, no? A is the larger part. So this will be A minus X. You are subtracting this part, so that's why you get A minus X. So at this neutral point, I know electric field is 0 because I have considered it as a neutral point. It means in net electric field, this is 0 at point N, which is my neutral point. All right. Now, for this, let's take the general formula of electric field. Electric field point charge is what? It is KQ divided by R square. Now, charge is E. Separation at this point N is X. What will be the electric field? Just put it in this formula. Madhya, you try. Madhya?
K by X square.
Ke by X square. See, Ke divided by X square. Since both the fields are cancelling each other, it means you can equate them. Rifat, you tell me, what will be the electric field because of 4E? Yes, Rifat. Just try. KQ by R square is the general formula that you have. What is the charge? 4E. 4E is the charge. And separation is what? A minus X. So electric field should be C. K will be there. Instead of Q, I have the charge as 4E. Separation is what? From this point?
A minus X.
A minus X. So R square, so it will be A minus X whole square. Is this clear?
Yes.
All right. Now, K will get cancelled. E will also get cancelled. Now, if you take the root of both the sides, you will be left with 1 by X is equal to 2 by A minus X. Just cross multiply. A minus X is equal to 2X. A is equal to 3X. X is what? X is basically A divided by 3. It means this part, this X is coming out to be A by 3, and A minus X means the rest of the part is 2A divided by 3. Clear? So if question asks you what is where the neutral point is situated from charge 4e, then write it as 2a by 3. If you know what is the separation, what is the neutral point separation from plus e, that will simply be a by 3. Just an idea. Why did I choose neutral point over here? Why didn't I write over here? And it came out closer also. The reason is that neutral point, this neutral point lies closer to smaller charge. It lies closer to smaller charge. That's why I took the neutral point a little closer to E, not at the center. Okay. So for some systems, you can take electric field as 0. See, if you get some questions like this, if you have a symmetrical system, always remember electric field for symmetrical system is 0. So this will ease your calculation. Electric field at the center of symmetrical system. Symmetrical system is 0. So if you get a symmetrical system, no need to do calculation, no need to perform any calculation. Just quickly write the answer as 0. For example, in this only, here we had E and 4E. The system was unsymmetrical, so we were getting the neutral point at a different place. If you have, let's say, plus Q charges there, plus Q charges there. This is an identical system. It means this is a symmetrical system. Neutral point will be situated exactly in the middle. Means if this separation is A, this separation is A. Had it been EE in both of them, in this, had it been EE or had it been 4E, 4E, your X would have come out to be A only, A by 2, separating it. Now, electric field for symmetrical system is always 0. Not only this, if you take triangle, Q, Q, Q is kept. This is an equilateral triangle. All the charges are positive. This is AAA. This is an equilateral triangle. And you are asked to calculate net electric field at the center of this triangle, equilateral triangle. No need of calculation. Quickly write it as 0. For a symmetrical system, it will be 0. If you have a square, 4 charges are present at the corners of the square, net electric field at the center, this will be 0. If it's a rectangle, then you have to check because sides are, that becomes your unsymmetrical system. Let's increase number of lines. Let's increase number of figures. Instead of 4 lines, it is having 5 sides. Means a regular pentagon is there. All charges are kept, plus Q, plus Q, plus Q, plus Q are kept. Net electric field at the center will still be 0. If infinite number of lines are added, these are 5, then 6, 7 till infinite, it becomes a what? It becomes a complete circle. So at the center of a circle, net electric field will be 0. So these are some quick ways to solve your question. No need to solve if you know that it's a symmetrical system. But as you see this kind of system where E is there and 4E is there, different charges are there, then quickly you understand that this system is not a symmetrical system. Net electric field means the sum of all the electric field. Charges, yes, electric field means all charges field, correct. So electric field for E will be, let's say this is E1, for B this is 4E, this is E2. Net electric field means E1 plus E2. This is net electric field. So since net electric field was 0, E1, E2, this was also 0. Clear, Fahad?
Ma'am, for this one, the distance x we took as a by 3, and then for the remaining, why did we take it as 2a by 3?
2a by 3. Yes. So this is not a symmetrical system. See, Madiha, had it been a symmetrical system, both the charges would have been 4e, 4e, or it would have been EE. Then this x value, just try it yourself after the class also. X value would have come exactly a by 2. Other half would have been a by 2, other half would have been a by 2. Since we know that this is an unsymmetrical system, for asymmetrical system, Just this is a hint. Neutral point lies closer to it. Now you take the value of x as this. You can take this as x, take this as x. Method will remain the same. At the end, ultimately, you will be getting this portion as 2a by 3 and this separation as a by 3. So whatever question is asked from the separation of whichever point, just calculate it. Clear, Madhya? You were asking this, no, na?
Yes, it's clear.
All right. So all of you just note it down. Then we'll see one more question. One question on superposition principle, the principle that we have just studied. Right now, no superposition principle was involved in this. This was just electric field for point charges. See, before starting with the next question, that involves superposition principle. So, superposition principle, as I've told you, that involves your simple vector addition. Now, just revising it, if anybody has forgotten what were your vector laws, vector addition laws that you have studied. Let's say this is both these are your two vectors. This is A vector, this is B vector. If two vectors represent the adjacent sides of a parallelogram, for example, this is your complete parallelogram, and two vectors represent the adjacent sides of a parallelogram, they have a certain angle between them, their resultant is given by the diagonal of the parallelogram. And the magnitude of the resultant is calculated how? Square of magnitude of first vector plus square of magnitude of second vector plus 2 times first vector multiplied by second vector multiplied by cos sine of the theta that you have, the angle separating them, with an under root sign. I'm not doing the derivation because now in your 12th standard this is not required. You just know, you should know the result and how to solve it. This is the magnitude, but a vector has what? A vector has a direction as well. So let's say this is beta. Tan beta, this is always given by this vector that is not made with the with this beta, take it as B, and the angle which beta with the vector with which the beta is making, take it as A, standardized. So you will always remember. So it is the opposite vector means B times sine theta divided by this vector A plus the opposite vector B times cos theta. This is the direction. If anybody has forgotten, I hope it is revised. If you wish, we'll be having more classes and you can get it clear. Now I'm giving you a question based on superposition principle. Take 2 to 3 minutes, at least try that yourself. Let's see who is able to answer it. Electric field will be given by what? You know the directions of electric field. So I'm giving you the question as well as make a note point or make a star point and write this. And I'm giving you a question here. Question number 2. So this is a square. Square is A. Now, had this been the question, okay, I'm just modifying the question. This is not your question. And at the center, I would have asked you the electric field. Can anyone tell what would have been the electric field?
0.
0. Yes,
Zero.
Samya. Correct, Mathiya. It would have been 0. Reason? Because it would have been a symmetrical system. Now, let's make it unsymmetrical and see how this is utilized. Superposition principle, this is utilized. Let's say this is plus 2q, this is minus 2q, and this is minus. So now this is unsymmetrical system. Separation is A, take these points as A, B, C, D. You have to calculate electric field at the center O. Now, one hint, at this point, first take whatever is the direction due to this charge, then take what is the direction due to this, what is the direction due to this, what is the direction. Then you will be able to relate it to this parallelogram. Direction, how is it taken? For positive charges, move away, for negative charges, move towards. At least try. If anybody gets the answer, send me in the chat box, and after 2 minutes, we'll discuss it. Still it is coming 0, Fahad. All right, let's check it. So let's see how to apply superposition principle. So this was your square that was given with all the charges q plus 2q minus 2q minus q. Now at this point, if you move away from this charge, no, it will lead you in which direction? It will lead you in this direction. This is EA, electric field due to this. This is how no, you will be moving. If you move in this direction, that will lead you towards the charge. But for positive charges, you move away. Similarly, this is also a positive charge. So you will move away in this direction. This will be EB. For negative charge, you move towards the charge. So moving towards the charge, this will be EC. And you're moving towards the charge, this will be ED. So see what you are getting. ED, EB in one arm, EC, EA in one arm. If you know the angle between them, if you add these two and if you add these two, you will get one electric field for this arm and you will get another electric field for this arm. You can add them. Both the vectors are in same direction. EB plus ED will give you E1 and EC plus EV will give you E2. Always remember the diagonals of the square are perpendicular bisector. So the angle between them, this is 90 degrees. So if you know E1, if you know E2, and you know the angle 90 degree, you will be able to get the net electric field. This is how the plan is set, how electric field is to be calculated. Now see, this is required, the separation from the charge and the point. That's how we calculate electric field. No, how is electric? What is the formula of electric field? Electric field's formula is kq divided by r square. We need this r. No, r is what? Separation of the charge from the point. So this is unknown to us. But see, you know this. You know this is A, you know this is A. So this will be what? This is hypotenuse. AC will be equal to AD. Both these diagonal, not AD. AC will be equal to BD. Both the diagonals will be what? Under root of A square plus A square. According to Pythagoras theorem, this is A, this is A. This is hypotenuse. Hypotenuse is given by square of perpendicular and base. So this will be 2 root 2 times A. So what will be AO? We don't need AC. We need AO, this part. We need BO. We need this CO. We need this DO. Separation of all the charges from this point. This will be equal to root 2A divided by 2. This can also be written as A by root 2. So all these separations are A by root 2. Now it's very easy. Just put the values of, let's see what are the values of EA, and firstly let us solve this arm. ED and EB. This arm, ED and EB. See, ED means what? ED is charge is minus Q. ED will be what? General formula is KQ by R squared. So K. Now at point D, see we are calculating electric field at point O because of this D point. D has the charge minus Q. We consider the magnitude of the charge. So it will be K divided by Q. R square, what is the separation? Separation from the charge and the point is DO. This is A by root 2. So it will be R square means what? A by root 2 whole square. This will be A by root 2 whole square. This is ED. So root 2 square will become 2 and go in the numerator. This will be 2Q by A square. EA. Again. So yes, Yusuf, tell us, in case of A, EB we are calculating, not EA. EB, what is the charge in EB? Yes, Yusuf. EB we are calculating. What is the charge at B point? Samya?
K plus 2Q upon
A by root 2 whole square. And K plus 2Q nahi. It will be K 2Q multiplied by 2Q. You won't take plus 2Q. All right, don't consider sign. Divided by R square. See, separation is what? Separation is BO. And BO is what? This is also equal to A by root 2. So this will also be, this 2 will go K times 2Q divided by A square. So this is 4KQ by A square. Now see, if you have ED with you, if you have EB with you, if you add both of them, ED plus EB is what? This is 4KQ by A square plus 2KQ divided by A square. This is 6KQ divided by A square. This is looking lengthy, but this is not so lengthy because we are discussing each and every point in detail. That's why it is taking time. So ED plus EB, this has been solved, 6KQ by A square. It means we have E1 with us now. One arm has been solved. E1, this is 6KQ by R square, A square. This is clear to all of you or not? Just tell me.
Yes, ma'am.
Yes, ma'am.
All right. Now we have to similarly solve for EC and EA. See, EC is what? Charges minus 2Q. So we will be taking the magnitude only. So EC will again be what? EC will be K 2Q divided by A by root 2 whole square. So this will also be 4KQ by A square. Similar to this, what we had calculated for B point. Then we have to find it for EC. See, EC we have done EA, charge is Q. If charge is Q, separation is A by root 2. What will be the charge? Rifat, now tell us. Charge is Q, separation is A by root 2. What will be the electric field? How are we calculating now? Rifat, just try. I'll help you. Constant will come or not? K will come or not?
Yes. K
K,
2Q.
not 2Q. Just look at the charge at A point.
KQ.
KQ. KQ. And separation, what is the separation?
KQ by
This is AO. See, AO we have calculated. A by root 2. So it will be KQ by
KQ by A by root 2 square.
whole square. Correct. Perfect. Perfect. This will be KQ divided by A by root 2 whole square. So root 2 will become 2 and it will, since it is in the division form, it will become in the numerator here. It will be 2KQ divided by A square. Again, add both of them. EC plus EA will give you what? This will be 6KQ square divided by A square. Now you have both of them. One is 6. This is also E, 6KQ by A square. This is also E, 6KQ by A square. Both of them have the same magnitude with the angle 90 degrees. Now apply superposition principle. Means parallelogram law. Net electric field will be what? E square plus E square plus 2 E1, E2. Since E1 and E2, both of them have the same magnitude. That's why I'm taking it as E. Cos 90 degrees. Cos 90 degrees 0, this term will become 0. Net electric field will be E square plus E square only. This will become 2E square under root. So E square, E will come out, root 2 will be left. What is the value of E that we got? We got it as 6KQ by A square. 6KQ by A square we got, and now we are just multiplying it by root 2. So this is your complete electric field. Clear to all of you now?
Yes, ma'am.
Yes, ma'am.
What about Reem and Yusuf? Clear?
Yes, ma'am.
All right.
Yes, ma'am.
Fine. So just note down the solution. Try to solve it yourself. Wherever you get stuck, then look at the screen.
Ma'am, why is
Yes.
KO is equal to PO 2 root 2A upon 2?
See, this is what? See, Samia, this side is what? This is A, B. This is A. This side is what? This is BC. This is also A. This is a right angle triangle. If you look at this part only this part, because obviously angle of the square is 90 degree. This is now according to Pythagoras theorem. This is the hypotenuse. This is your base and your perpendicular. Then hypotenuse square is equal to perpendicular square plus base square. This is your Pythagoras theorem. So hypotenuse is what? This is AC. AC will be equal to under root a square plus a square. That becomes 2a square. 2a square with an under root. So a will come out. Under root 2 will be left. So a by o is what? Half of AC. This is O point. That's why if this whole is root 2a, this will be root 2a divided by 2. And if you multiply it by root 2 and divide it by root 2, see, root 2 multiplied by root 2 gives you 2. That 2 and 2 gets cancelled. So you'll be left with a by root 2. Is it clear or should I repeat once more?
Here, ma'am.
Clear? All right. Written?
Yes, ma'am.
Yes, ma'am.
All right. So electric field for point charge, this is enough for it, superposition on it. Now we have dipole moment with us, and then we'll be relating dipole moment with electric field. But before that, you have to understand what is meant by dipole. For dipole, you should know what is a monopole. Mono means what? Mono means single. So all the systems that have only one type of charge there. Only one type of charge. It means what? There are two types of charges. So either positive or negative. For example, if I talk about an electron, electron is a monopole. Reason? Because it has only negative charge. If I talk about proton, proton is also a monopole. Reason? That it has only positive charge. Now, dipole is what? Dipole is system where you have a positive charge and an identical negative charge. Means a positive charge and negative charge, both of these charges are there. Both of these are having the same magnitude. Like if this is plus q, this will always be minus q. And they have a small separation between them. Let's say this is small, this is 2a, this separation. So this is called as a dipole. So again repeating, dipole is what? Monopole was what? Monopole means a system that has only one kind of charge. If it is negative, it will only be negative. Have you ever heard of electron being positive? Never, because electrons carry only negative charges within them. Regarding protons, protons always are positive. You have never heard of any proton that is negative or the proton transferred negative charges. First of all, protons do not move and do not contribute in transfer of charges. It's the electrons that only move. And electrons also, in electrons also, you have only negative charges. So those are monopoles. In case of dipoles, both the charges should have the same magnitude. It's not that positive and negative charges will make your dipole. Positive charges, positive and negative charges will make your dipole. But the condition provided to it is that both the charges should have the same magnitude. For example, if it is minus 2 coulomb and plus 4 coulomb, this does not form your dipole. Reason? Negative charge and positive charge is there, but both the charges are having the different magnitude. One is having magnitude 2, other is having magnitude 4. If it is minus 2 coulomb and plus 2 coulomb, then only you call this set as a dipole. So a system, this is called a dipole. This is not considered as a dipole. So a system having equal amount means both have the same magnitude. So equal amount of positive and negative charges at a small separation between them. This is the definition of a dipole. For example, in your chemistry also you must have studied dipole moment. I think in 11th you must have studied. If you have a molecule of HCl, then it has positive hydrogen atom, it has negative chlorine atoms. This is also a dipole. NaCl, Na has positive charge, chlorine has negative charge. This is also a dipole. If both the charges have the same magnitude and both of them have opposite direction and are separated by a certain distance, you call it as a dipole. Now, regarding the dipole moment, what is the term dipole moment, which you might have heard of? Basically, whatever is the strength of the dipole, that is known as dipole moment. It gives you the strength of the dipole. It gives the strength of the dipole. Whatever is the strength of dipole is given by the dipole moment. Now, how is it calculated? Dipole moment, how is it calculated? See, ideally what we take? We have taken a positive charge and a negative charge, and by convention we have assumed that the separation between them is 2a. It could have been a, but we have taken it as 2a because by convention it is set that separation between the charges for dipole is taken as negative of a. This has been taken. Now, how to calculate the dipole moment? It is represented through the symbol p. It's also a vector quantity. Take magnitude of any of the charge. Both of the charge have the same magnitude. So take any of the charges. Let's say q. Don't consider the sign, just take the magnitude and multiply it with whatever is the separation between both the two charges. This is your formula of dipole moment. It's a vector quantity. If it's a vector quantity, it means it will be having magnitude as well as it will be having its direction. This is what is meant by dipole moment. This is the formula of dipole moment. Never double the separation. If the separation between the charges, this is 3 meters, then take it as 3 meter only. Your 2a will become then 3 meters. If suppose, let's say this is plus 2 coulomb, this is minus 2 coulomb, separation is 3 meter. So 2a becomes 3 meter. You don't need to multiply 3 by 2 and get it as 6. 2a is the separation between the two charges. Now, if it's a vector quantity, it has a magnitude and direction. Magnitude is given by this q multiplied by 2a. But what about the direction? So see, direction is from the negative charge to the positive charge. This is the direction of dipole moment. One more thing. All of you write me in the chat box right now, what should be the SI unit of dipole moment? Charge SI unit you know, length SI unit you know. Multiply and tell me, all of you. Quickly answer. What should be the SI unit of dipole moment? This is the formula. Charge multiplied by 2a. Madhya, you are dividing it. See, charge is getting multiplied. Yes, Samya. Samya is right. Yes, Rifat. Rifat is also correct. Yes, now Madhya, you are right. See, SI unit of charge is what? SI unit of charge is coulomb. 2a is what? 2a is basically the, and the SI unit of length is what? This is meter. So SI unit becomes coulomb meter. Clear dipole moment?
Yes, ma'am.
All right. So just note down all these points.
Ma'am, if the separation was T, the formula would have been P is equal to Q by D, right?
Q is P is equal to Q multiplied by D. Yes, yes.
Yes.
Just take the separation. Just this 2 is just a confusing factor. Never multiply anything by 2. It's
Okay,
just
ma'am.
that take the separation. You have two charges with you, plus 2 millicoulomb and minus 2 millicoulomb. So both of the charges have the same magnitude, 2 millicoulomb, and the signs are also opposite. It means it is forming a dipole. Now the separation between them you are not aware of. You have to find out the dipole moment. Dipole moment's formula is what? This is charge, magnitude of any of the charge multiplied by the separation between them. Now regarding the charge is what? This is 2 millicoulomb. Is it in its SI unit?
No.
So we have to convert this milli. It means this will be 2 multiplied by 10 to the power minus 3 coulombs. This is your charge. Separation. Can anyone tell me what is the separation? Did anyone calculate it? 2A. Nobody? See, coordinates are given to you. It means from the origin, this point is written as minus 2. It means you must have done this in your graphs. This point is origin, so this would have been minus 1. This point is minus 2. So this is what? This separation becomes? This separation becomes what? This becomes 2. This is 2. Reason? And these are in millimeters. Okay, so this becomes 2 millimeters. Why? Because this is 0, 0, minus 2. If this is origin, this is your axis, z axis, then this point would have been minus 1, this point would have been minus 2. How would you write this point? You write this point as 0, 0, minus 2 only, no? Why? Because minus 2 is representing, this is representing x axis, this is representing y axis, this is representing z axis. So at the z axis, you have the charge as minus 2. It means this separation is 1, this separation is 2. So that's why this separation becomes 2 millimeter. This negative sign just shows that this is located on the negative z-axis. Similarly, for this charge, from the center O to the charge, this separation is what? This separation is again 2 millimeters. Now, can you tell me what is 2A? What is the separation between the two charges, 2 millicoulomb and minus 2 millicoulomb? Now it's written in front of you.
2 millimeters.
Yes, right. No, Fahad. See, Fahad, that is separation from the origin. Total separation between them will be this whole, no? This much. So this is 4 millimeters. So again, we have to convert it 4 into 10 to the power minus 3 meters. So dipole moment is what? Charge multiplied by 2A means the separation between them. Charge is 2 into 10 to the power minus 3. Separation between them is 4 into 10 to the power minus 3. This becomes what? 4 multiplied by 2. This is 8. Yes, fat. So it will be 4. 4 millimeters because this is given in millimeters. So dipole moment will be 8 multiplied by 10 to the power minus 6. Now see, writing this is not sufficient. It is 10 to the power minus 3 because 1 millimeter is equal to 10 to the power minus 3 meters. So if you have 4 millimeters, this will be 4 into 10 to the power minus 3 meters. Wherever you have milli term, no, just replace it by 10 to the power minus 3. Yes, Madhya, total separation is 4. So 2A is 4. What is 2A? 2A is the separation between the two charges. That's what I've told you, no? Do not double it. Separation between the two charges is 2A. It means here the separation between both the charges is 4 millimeters. So 2A becomes 4 millimeters. Had it been this only, this would have been given. Then you would have doubled it to get 4 millimeters. Is it clear, Madhya? All right. So the separation between the charges you have to take. Don't get confused by 2A. 2A is just a set formula. Had it been A, or the way someone was asking also, had it been D, it would have been Q multiplied by D. Just take the separation, never double it. So dipole moment, see, this is the magnitude. Since it's a vector quantity, we have to consider the direction as well. So what is the direction that I told you? Just look into your notes. What you have written? What is the direction of dipole moment?
Negative to positive.
Negative to positive. It means from the negative charge, this is your negative charge, to the positive charge. Means in this manner, this is your direction of dipole. So it is pointing towards, it is leading us towards which axis? Positive z axis. Does anybody know what is the unit vector for positive z axis? I cap, j cap, k cap,
K cap.
k cap. So your complete answer becomes what? This is the direction of dipole moment. So your complete answer, this becomes 8 into 10 to the power minus 6 k cap, then coulomb meter. So write down the solution as well as the question who have not written it, and if you have any doubts, then ask me. What about others? Done?
Yes, ma'am.
Yes, ma'am.
All right. So I'm stopping here today.